My name is Vira, so I'm a Chief Data Officer from Lippo Group. So maybe before we explain about what is the material of the use cases that we would like to share to you, so maybe let me explain a bit to you about what is a Lippo Group, which is actually we are part of the largest conglomerate in Indonesia. Okay, this is the corporate assets that actually is part of our group that actually we serving around 1.2 million of the Indonesian consumers. That actually, as you can see, that this is part of our business that we own the wholesale supermarket, we own the pharmacy, convenience store, bookstore, hotels, hospital, we own coffee shop, e-commerce. Then we also meaning like online, offline business at the same time. So we own the cable TV, satellite TV, properties, which is part of the housing, and office as well. Then we own the cinema, TV media, news, malls, data centers, SI. We also own parking system. We are also one of the largest EDC operator in Indonesia. We own bank, insurance. For the education, we own the university, I think around 50 schools as part of the organization. Entertain, asset management, venture capital, even we also own the cemetery. So I think this is part of the Lippo Group present in all aspects in the consumer life. So you can see some of the logo there that actually part of the retails. We are one of the largest retail in Indonesia. Then hospital, this is also like one of the largest hospital in Indonesia. Many things, but now the next question is actually when we have the Lippo global footprints and also like the domestic business one. The next question is how actually Lippo Group developing this kind of the big data. Because if you work for the telco background or let's say like for the financial institution, usually part of the data source is actually coming from the single industry. But our big data is dealing with the diversity of the data coming from the, multi-vertical industries. So it's kind of the challenging because when you speak for the telco data, usually you have the identity of the customer. But for retails, because mostly our business operating for the retails, most of the customers that coming to your stores actually not providing the identity. Then how Lippo Group that actually we deliver the big data using this kind of the retail, which is part of our major business. So when you see this logo of the OVO things, OVO is actually the integrating mobile payment, loyalty, including for the providing the priority deals. The intention is how that our loyal customer pretty engaged with all of our business. So OVO is becoming like the linkage, connecting all the source of the data, including like the services. So we work together with the external merchant. So you can see that on top is actually part of the Lippo Group asset, but below is actually part of the external merchant that actually accepting OVO for the payment and also for the loyalty. So when you see this picture, this is about the Lippo Group, which is part of the OVO Big Data as well. That on the left side, you can see that it's going to be a lot of data source coming from the multi-industries. If you see that the picture there, which is with the color, actually that's the one that becoming our priority. It's mostly about the retail. So I'm going to explain to you later on actually why we're focusing the retail data at this moment. So actually our big data start in terms of the journey is like this year's April, 20th April to be precise, start with the 6 people only. So maybe it's just around like 7 to 8 months, 8 months in progress. So this is the way how we actually executing the big data. So it starts with the initial phase. Our major focus is actually to develop the 360-degree profile of the customer. So the 360-degree actually is not only for the individual, but also for the household, then for the stores. It's applied per subsidiary, and also apply for the consolidated of the data. So in the next stage, then we can talk about how to deliver the big data in the form of the API and start to do the monetization. So you can see that on the right part that there are internal and external. Internal is meaning that how Lippo Group, our internal business, is going to utilize the big data and how external can interact with us. So when we speak about 360 degree of the customer profile, actually there are a lot of attributes that we would like to explore, to see from different point of view. So we can see from the emotional, we can see from the brand sentiment, which is positive or negative. So there will be a lot of attributes actually attached to per individual customer. This one of the sample of the 360 degree of the individual customer profile. So if you see from this diagram that actually you can see from the different angle, for example, like, she's pregnant. The thing is, how do we know that she's pregnant? Because we own the retail, so meaning that we can see from the customer baskets all the product that actually this customer consume. Then how do we know if she had kids and if the kids is actually girl? Then next is actually if she plans to travel soon. So the story of this text is actually how you can really fully utilize your data source to really can tell into a deeper, what is your customer's preference or customer's behavior. Then in the next journey, actually, after you know this kind of the figure about your individual customer, so meaning that you can start to think about what you're going to offer to them. So the meaning of this in the next stage is actually about the personalized offer. Now, previously I explained about 360 degree for the individual customer profile, but this one is for the household. Because we own the telco for the fixed broadband, so meaning it's about describing the household profile. So for example, that what is the connected device in the household? So we can see that actually what is the mobile phone brand type, the operating system. We can also understand that most of the data usage category, the consumption. We will understand that actually what is the family lifestyle and the segment. Even like what kind of the TV program that the customer watch, so we can see, let's say including in what time. So we can also understand, let's say if this family, they prefer to stay during weekend or they would like to going to the mall and so on. So this is the profile of the customer per household. This is something that apply for the store. Because like I mentioned to you that we also own the supermarket. So you can see that actually the attribute attached to the store is actually different. So you can see that actually this is our convenience store that we own downstairs in our lobby level in office. So we try to identify what is the customer behavior, they're purchasing, what they like. So actually I can tell you that what the customers like when they purchase in the convenience store inside the office building, actually it's only three things. It's about they purchase drink or water, snacks, then fruits. But typically like the female customer and male customer, they have their own different preference. And the thing is, after we know about this kind of profile which is applicable for one of the store, that what are we going to do? So next thing is about customer journey. Previously I mentioned to you that there are three of 360 degree profile. But now let's think about how to understand the customer journey. So what I put in the picture here that actually we try our best how to make our customer engage to the whole services that we at Lippo Group is providing. So if we understand better that actually customers, what they're doing in the beginning of the month, usually what kind of the malls that they like to visit. So let's say even we understand that actually the e-money that they're using is actually running out of balance. Maybe it's going to be the right time for us to start offering the loan for the customer to engage. So by understand the customer habit and behavior pattern, so meaning that it's going to be the right momentum for us to start offering things, because that exactly will be the moment when the customer needs it the most. So this is the benefit that we are getting to be delivered by understanding this 3 point of view of the customer's 360 degree. About the individual customers, meaning that we can do the target campaign, improve customer experience. But then if we develop the 360 degree for the store profile, meaning that each of our stores is going to have a different design. So how are we going to optimize it? So it's going to be different situation based on the location, based on the surrounding as well. For the household profile, so it's about improving customer experience for sure. The next thing is how we can deliver the right advertising. Because when the customer is subscribing the cable TV, meaning that we can push the right ads to the TV channels, because we understand the whole profile of this household. Now, this is a simple thing as well that we try to do by developing the 360 degree customer individual profile to our coffee shop. We own Max Coffee. So you can see here that there are name, age, and the thing is, simple thing that we understand what is the top 3 favorite drinks the customer like, food as well. Then we also do the simple segmentation. For example, like what is the product segment tendency? Let's say it's kind of the beverage dominant rather than the food dominant. Then what is this customer spending life stage? Let's say for this one is declining. Sorry. So as a marketing, when you have this kind of the figure, so very easy for you to just like do slice and dice to the filter. For example, like how many customers that actually when the spending life stage is declining. Then the next thing is, what are you going to do by knowing this? What kind of the program or deals that you're going to start to offer to your customer to keep them pretty engaged and coming back? So the thing that we plan to do with this is actually try to do the personalized offer to the customers, being personalized. So meaning that when we distribute, let's say like the deals using the OVO apps or using the email, so I'm going to receive the picture of the content of my the drink that I like. But the thing is, I don't need to pay because I have a lot of points. Meaning that we're going to encourage our customer to get a coffee of what they like without need to spend the money. Then we will try to understand whether the customer is coming back and they engage or not. Now talking about the API. So each of the attributes that I put here that actually you can convert it as the API in an easy way. How to consume actually. So because we own the apps, meaning that when our customer, they visit our store, they can just tap the barcode or the QR code. Then the barista will understand about what is customer preference. So they can start to do, some kind of the personalized conversation because they know what's customer like. In the next stage, actually, is for sure you can do like the machine learning implementation to design the next best offer for the product recommendation. Okay. This is also part of the individual personalization deals. This is still the same customer attribute attached for individual customers. If you see this, that actually, what is the top merchant that customer regularly visit? So actually, knowing these figures, so you're going to pick the deals or the promo based on what the customer likes. So each of the content is going to be something that personalized. It's only a matter of how you're going to broadcast the message. Is it like through the apps, SMS, or is it going to be like through the email? Now, this page is going to explain a bit about our monetization plan. So we do not plan to do the monetization like, by selling the insight of the customer behavior. What we plan to do is actually how we can deliver a new smart digital channel to interact with the customer. So this smart vending machine actually is not selling things. This is designed actually to distribute the product sample owned by the FMCG. You know, doing the vending machine business actually is not really making money, especially if, let's say, the product that you're going to sell is like cheap one, because the cost for the, you know, for the operation, the chiller and so on is quite expensive. So by doing these things, actually we're distributing the FMCG, because you know what the FMCG needs? They would like to understand who take their product sample. Simple thing like what is the gender. Then later on what we're going to provide actually the dashboard. So FMCG can see that in which vending machine the customer prefer to take more of the product, and then we can, for example, like embedded the camera to check the crowd and do the facial recognition to understand, to capture the identity. So we can tell the FMCG, this is the profile of the customers who's taking your product sample. But the next thing that actually, what is the customer journey? What is the customer lifestyle? If the customer is taking this product, this is this profile. For the customer, let's say like just walking around in front of the vending machine, this is also the profile. So next thing, of course, FMCG would like to get a channel how to reach out the customers. So we provide the dashboard for the customer to enable that kind of the capability to filter out the information of the customer. Then later on, they can like distributing the message by themselves. Now it comes part to the technical one. This is the philosophy of our big data technology actually. So you can see from the bottom level is part of the ETL, which is part of the data integration. Then we using the Hadoop for the storage. So the data coming from multi-industry, going to the landing zone, staging to the goal business layer. That's the environment is CPU based. Then on top of that layer, actually we using the in-memory DB. On top of that is going to be the API layer. The intention is the output of our big data is not only about the insight or the business reporting, but most of the deliverable actually in the form of the API. Maybe it's going to give you more detailed information. So most of the retail data, hospitals, actually is come to the Hadoop. So if you see that actually in terms of the ETL tools, we're using the Informatica. It's not appliance, it's just we purchase the license. So actually all of this technology is running on top of the Hadoop, fully utilizing the Hadoop computing power. So that's why we're not implementing the appliance at all. So after that, everything is going on under the Hadoop platform for the aggregation to generate the insight and so on. Then the next stage is actually we offload the data into the in-memory layer. So then we release the API one, how the customer touchpoint can start to consume. This is more illustration about how we deliver the output of the big data, then how customer touchpoint can start utilizing it. So you can see for the data source part, there are a lot of customer information there as part of the data source coming from the multi-industry. But then after that, actually how the data is flowing to the Hadoop. There are 360 degrees of the customer profile. Then they are also aggregated inside. Then in the in-memory database, we load that kind of the information, a selective one. Let's say if we would like to do the credit scoring. So the processing part is happening in the Hadoop. But the scoring result, we load it into the memory. Then later on, we encapsulate the information as the API. Then you can see on the top layer, that's for the customer touchpoint channel. How of apps, vending machine, digital signage, any apps can fully utilize it. So customer touchpoint channel is going to be the one that orchestrating the business, business process. Now it's about deliver the targeted offer using GPU and analytics. Actually, the core part is actually about how the enterprise agency can start, do the slice and dice, the filter of the data by themselves, and later on how to reach out the target audience using selected customer touchpoint. This is about the API marketplace. Please excuse me. This is part of our monetization target as well. How we can integrate API and connecting to other organizations. Excuse me. So you can see here there are two types of the API actually. Left one is about the atomic API. So like credit scoring, segmentation, buying power. That's the one that as an attribute attaching to per individual customer. On the right side is about the analytical API for the insight, meaning it's going to be like a little bit heavy one, running based on the schedule. So on the player, it's about how our customer can do the registration and do the onboarding process to subscribe. Okay, this is a simple video demo that actually prepared by my teams about how actually that we can deliver the simple dashboard for our merchant actually to identify that among thousands of the merchants that we have today, actually what kind of the dev performance. Actually, it's a really simple thing that we're doing using the right technology, so you can see the figure of the performance of each of your business. Seems like the sound is not being played. Maybe I should start again. Okay, actually, in order to deliver this dashboard, is just really not really taking a lot of effort and time, because the simple thing that you just like aggregate your data coming from the merchants, then later on some of the aggregation actually coming on the fly. So, but this kind of simple thing actually that we can just replicate it in Lippo Group business, because like I mentioned before that we own the retail data, banking, and so on. So actually, not many cases that actually really dealing with the difficulties for our big data engineer team to deliver this kind of. So I think to get you more clarity about how the technology really works, so after this I need to pass the stage to my colleague Amit Vij as the founder of the Kinetica technology. So thank you.
All right, so as Vera said, I'm Amit Vij, one of the co-founders of Kinetica, and we're a next-gen analytics database platform. We started back in 2009 with the U.S. Army Intelligence Command, And pretty much our organization was going from a document-based search to entity-based search, where we were ingesting over 200 different data feeds. And this included a variety of different data coming from sensors. Data was, let's say, signal intelligence coming from mobile devices emitting their metadata every few seconds. Drones that are flying in the air, tracking any entity that moves. Social media to include Twitter or Facebook, and even cyber data, which is one of the hardest data feeds to process in real time because it's coming in so quickly, never stopping, and the payload is so large. So our government projects had pretty much a black budget, and we had enterprise licenses of Oracle and SAP, hundreds of nodes of Netezza, acres of Hadoop servers. I'm exaggerating, of course. But we went through many different technologies, and we saw the pros and cons of all of these. And the fact is that many of these technologies couldn't scale because they couldn't handle real-time ingestion and processing simultaneously. So we started initially as a geospatial and temporal computational engine. And at the time, our science advisor was like, I've never seen 10 million points be filtered in my life. And we ran this on Oracle and took 92 minutes. Then we utilized a variety of different technologies to include Hadoop and every single flavor of NoSQL database to ultimately land on GPUs. And we could do this processing in milliseconds. So we saw the same challenges that we saw in the military, commercial organizations are facing as well. And this is because the explosion of data. There's data that's structured and unstructured coming from a variety of different sensors. I'm sure everyone's heard of Internet of Things. You have industrial IoT and consumer IoT, and fusing these data feeds together to get more enriched analytics in real time. And current technologies we see are either I/O bound or compute bound. And organizations are going from COTS solutions to open source products, and they have to integrate 5, 10, 20 different technologies that are on different release cycles. And essentially, it feels like they're duct taping a solution together. And once they do this, they can spend months, years to put something into production, but you're still batch oriented and you're not getting data in real time. So very complex to put a solution like this into production. So what we essentially done is GPU accelerate traditional database operations. This is aggregates, group by, selects, and when we did this, we saw over 50 to 100x, if not more, performance gain on a fraction of the hardware. And this is because we essentially created a database from scratch, aligning the data to the cores, the thousands of cores of the GPU. So the average GPU nowadays has over 5,000 cores, where you can put very easily 2 to 4 in a single server. So you have 10 to 20,000 physical cores operating for you, as opposed to tens of cores in the CPU realm. So we say we're giga-threading per node rather than multi-threading per node. Built into our technology, we have NLP-based full-text search. So you can do traditional regex type of searches, wildcard character searches, but also more sophisticated searches like n-grams and fuzzy logic search. Being incubated as the geospatial and temporal computational engine, we have native objects for GIS. So very akin to like a PostGIS or Oracle Spatial, so to support points, lines, polygons. We work on a number of different cyber projects, so we have a native IP address type as well. So we found that once we create a native object for a specific data type, we get so much optimization and deliver extreme value to the customer. So we literally scale out on commodity hardware. We're an in-memory database, so we like nodes with a lot of memory. So a typical node would be around like a half a terabyte to a terabyte of RAM per server, with 2 to 4 GPUs within the server. And we have deep integration with Hadoop. So we read and write HDFS files. We read and write RDD files to Spark. Integrate with like ingestion frameworks like Niagara files. Integration with Accumulo. We have a ODBC, JDBC connector, so we're SQL 92 compliant. So business intelligence tools such as Tableau, Power BI, Qlik can all seamlessly use us through ODBC, JDBC. And we also talk elastic. So if you have, you could take off-the-shelf Kibana and slap it on top of us and get real-time results rather than waiting and binning data. And then one thing that's different from us, we're different from other operational databases is we have a distributed visualization pipeline built in. So one of the largest bottlenecks in a software architecture stack is moving data. Your data can be billions of objects, and moving this data from the database to analytics engine to like a machine learning cluster, and then ultimately visualizing that data to the user. So we're trying to short circuit many of these steps and take advantage of data locality. And with regards to visualization, we can render, using the same GPUs that render video games, we can render pictures and even videos that are created on the fly during the time of query. So this is a typical architecture here. We work very nicely with Hadoop. Many times we act as that hot layer, the data in motion. So we're called Kinetica. So really focus in on streaming big data, high velocity. And this can be multiple taps, which we can fuse together. And using ODBC, JDBC, we can talk to, if you have an authoritative data store such as Oracle or Teradata, and your dashboards or your analytical use cases are taking, several minutes or hours to compute. We've had many case studies where we're giving, extreme performance on the fraction of the hardware cost and overall ownership of our technology. So here's a little bit more of detail. So everyone's using Kafka out there or whatever your streaming processing technologies are. We're Confluent certified, so taking data from Kafka, or if you're using Spark SQL or Spark Streaming, or Niagara files, TIBCO. We have RESTful endpoints, so very easy to ingest data into us. So we've demonstrated on a 10-node cluster, we ingested 4 billion objects a minute with 70 different attributes with primary key off. And with primary key on, it was 1.3 billion objects a minute. And while we're ingesting this at this high throughput, we could simultaneously run queries, very complex analytics, and show results to the end user. We also integrate with, so we have a user-defined framework capability. So you can register any type of library, and we package in Google TensorFlow as with machine learning. That's one of the we see really in abundance in the field. But other ones like Cafe, Torch, or even we have customers with their own proprietary code that they want to accelerate and work on top of billions of objects in databases. So you can execute all of that just purely through SQL. And we linearly scale out on commodity hardware, and then we have open interfaces to get the data. So as I said, sending data to and from Hadoop, or like through ODBC, JDBC, we can send it to business intelligence applications such as Tableau, MicroStrategy, and others. And I'll show you an example of this. So how many of you guys have heard of Michelangelo? It's Uber's machine learning platform. So this is out there. It's pretty well documented, but Uber is using this to predict, what accurate, like they're trying to be accurate in when, if you're ordering like something to eat from Uber Eats, or you're ordering an Uber and it says, my Uber will be here in 5 minutes. So this is a pretty complex architecture where it has like an offline, architecture as well as an online architecture. and multiple different data stores. So you have a online and offline data cluster for Cassandra. You have that's taking data from Hadoop, and then you have a high feature store. You're using Spark SQL, Kafka, Spark Streaming. Organizations, enterprise commercial organizations, this can take several years to put into production. And if you're able to do so, you're still going to be batch oriented, as you have your data segmented in offline and online clusters. So we have the power, the raw horsepower using the GPUs to take advantage of, as I said, data locality for one thing, but aligning the data to the GPUs, running database operations, so finding your training set, evaluating that, running different machine learning models. All of this, we can be a complete solution, but also you can leverage our technology in multiple different ways depending on how your architecture is created. So to get into, let me get a time check real quick. Okay. Let me just show demos real quick then. So this should be a little bit more fun. So as Vera was just showing you, this is just like a GUI that someone created, but this is running on an 8-node Kinetica cluster, and this is showing flight data from the FAA. And essentially, every time I zoom in or out, it's a new PNG image that's created on the fly. And this right now is 610 million flight positions. So all I'm sending to the web browser is a 200 kilobyte PNG image. So I just clicked on a location and I get a cursor to over 2.8 million results. And I'm cursoring through and you can see where flights are traveling and the associated metadata. So I can do an arbitrary filter and say, show me all flights with an origin of ORD, O'Hare Airport in Chicago there. So you can see very quickly we're running multiple different operations here. So we re-rendered the heat map. We recalculated the histogram on the fly, and then I can do an arbitrary filter here. So like you don't need to bin your data every one day, every 24 hours, or whatever your fixed intervals are. We're all computing this on the fly using the brute force computational power of GPUs. So you can see very quickly, I go down in my query chain, and now I get 1.5 million results. And then I can say, show me all flights above a random altitude. So I don't have to have fixed intervals. So we really function as like a discovery platform and being able to do arbitrary filters on the fly. So next, I'm going to show you Reveal. This is our visualization framework. And I'm going to essentially show you that same data set, flights, but all this GUI, this is from Airbnb. It was initially called Caravel. It's now called Superset. But within this, we've created a variety of different widgets, and it's that same 610 million data set. But here you can see the top destination airport and origin airports, the altitude, speed, and a variety of different things. So I can just start clicking on the fly and doing an arbitrary filter and saying, show me all flights with a departure airport of Denver. And these are like all the top airports that, with that origin, and then seeing the average altitude on the fly. But then I can do an arbitrary timeline filter. And here you see, the top planes. So very, very robust and extensible in our capability. And we look like a relational database. So I know I'm over, so I'll just leave it there and go for questions. Huh? Oh, Yeah, if you have other questions, just come by our booth. I don't know what our number is, but right towards the front. Kinetica. Oh. Yeah, so great. I can even show you that. So if I go into Twitter right here, this is 4 billion tweets. So this is real-time data, and I just turned on the sparkles, but every time you see a sparkle, that someone's tweeting right now, and we're adjusting off the 1% garden hose, and that's around 1.5 to 2 million tweets a day. But I can just do an arbitrary filter on, let's say, Trump is very easy to do, and you can see tweets from the time we're ingesting and like 1 day prior. But I can do more sophisticated types of searches, such as like an n-gram, as I said. So if I say, show me all tweets with rain and tire within 5 words of each other, this is an n-gram or proximity search. Now, like if you ask Solar or Elasticsearch this result, they can give you an approximation and a few pages if the result set is very small. But if it's large and you're like I'm saying, hundreds of millions of records, that's going to take those technology hours to do. So if I search, so let me just show you the result here, and I can show you what I mean. But here's rain, all tweets with rain and tire within 5 words of each other. But I can do something that will give me a very large data set. So searching for haha. This is probably one of the most prevalently used words in Twitter. So my record set is 25 million plus results, but this is a precise amount with this real-time streaming data feed coming in. And now I get all tweets with haha. So if I run that same query, it's spelled J-A-J-A, so haha in Spanish or Portuguese, you can see, concentration of where people are laughing in South America, Spain, Mexico, and other areas here. Yeah. Yes, it is. So we actually have a demo of that. So this is off of Reveal, but sentiment analysis is very subjective, and there's different data feeds that specialize in specific data sources. So we just did something very easy and did sentiment based on emojis, smiley face, neutral face, or frowning. And so here you can see pretty much the breaking up here, and you can apply different renders to this, hot, cold, red for whatever your color scheme is. But yeah, I mean, this is exactly what we're doing here. So if I click on a location, you can see, the tweet, and I can cursor through. But if I start searching on, let's say, I can do Trump again, and during time, and then I can fix on a specific time and see if this is really accurate. But we can integrate with any kind of sentiment analysis engine. You usually do that in line as you're ingesting tweets, and they'll give out a score, and you'll place that in our specific field, and you can just render those results accordingly. Yeah, so we definitely can. So I don't, like you're saying, sentiment analysis based on like events or something like that?
Let's say we have our own model we want to use as a user-defined function.
Yes. You can have code in Java, Python, register that in, and execute that against data tables as an input table, and then push out an output table with the corresponding result, and then run other types of filters. I can try to even show you an example of that. All right, he's telling me I have to get off stage, but thank you for your time, and if any other questions, please come to our booth. Thanks.